It's easy to become lost in a mixture of wonder and relief when considering the question of how many extinct animals have roamed the planet. The natural world of the past, when fearsome creatures dominated the land, sky, and seas, is very different from the world we know today. In certain instances, the extinction of certain animals has benefited the development of human society and the security of the natural world today. This video explains why there are reasons to be happy that some extinct animals are no longer extinct, despite the inherent loss. Inhabit the same planet, concentrating on a small number of extinct animals, such as the massive clawed dinosaur Therizinosaurus, the marine monster Basilosaurus, and the enormous Basilosaurus, the killer whale of the past. Basilosaurus, often regarded as the killer whale of the past, presents a fascinating glimpse into the marine life that once dominated the oceans. This ancient cetacean's existence sheds light on the evolutionary journey of marine mammals and the dynamic ecosystems they inhabited. Size and description. Basilosaurus stands out for its immense size and unique physical characteristics that set it apart from modern marine mammals. Measuring between 17 to 20 meters, 56 to 66 feet in length, and weighing over 5.8 metric tons, 6.4 short tons, B. cetoids was one of the largest animals of its time. Its counterpart, B. isis, slightly smaller, still measured an impressive 15 to 18 meters, 49 to 59 feet, and weighed nearly 6.5 metric tons, 7.2 short tons. Unlike any other basilosaurids, Basilosaurus was distinguished by its larger body size and more elongated posterior thoracic, lumbar, and anterior caudal vertebrae. Its body was sleek, resembling that of very large eels, with small limbs at the back likely aiding in mating rather than locomotion. The creature's narrow snout was lined with teeth of different shapes, including multiple large serration-like cusps towards the back, indicating a diet that included larger prey. Habitat and era. Thriving in the warm tropical environments of the Eocene, Basilosaurus inhabited areas abundant with sea grasses such as thalassodendron, thalassia, and halidol. Its fossils have been discovered in regions that were part of the prehistoric Tethys Ocean, which, over millions of years, transformed into the modern-day Indian Ocean and Atlantic Ocean. This indicates that Basilosaurus was a fully marine creature, living exclusively in saltwater as evidenced by the oxygen isotope chemistry of its teeth. The presence of Basilosaurus fossils in Egypt, Northern Africa, Jordan, Tunisia, Morocco, and Pakistan, as well as in the American South, especially in Alabama, Louisiana, and Mississippi, highlights the widespread distribution of this ancient whale. Feeding habits. Basilosaurus was the top predator of its environment, primarily feeding on fish and large sharks. Analyses of the stomach contents of B. cetoids have revealed a diet consisting exclusively of these marine creatures. Interestingly, bite marks on the skulls of juvenile Dorodon match the dentition of B. isis, suggesting a dietary preference for this dolphin-like species, similar to the dietary differences observed in modern killer whale populations. The discovery of juvenile Dorodon at Wadi El Haytham, bearing distinctive bite marks on their skulls, further supports the theory that Basilosaurus aimed for the skulls of its victims to kill its prey. This apex predator likely hunted newborn and juvenile Dorodon, tearing its meals apart based on the disarticulated remains of Dorodon skeletons found in the area. Basilosaurus's role as a formidable predator in the ancient oceans is undeniable. Its size, unique physical characteristics, and predatory habits underscore the diversity and complexity of prehistoric marine ecosystems. As one delves into the life of Basilosaurus, it becomes evident why this ancient cetacean is often referred to as the killer whale of the past. Therizinosaurus, the giant clawed dinosaur. Physical characteristics. The Therizinosaurus, a behemoth from the late Cretaceous period, approximately 70 million years ago, is renowned for its unique and formidable appearance. Known primarily through forelimb skeletons, this dinosaur's reconstructions are largely speculative, yet consistently depict a creature of immense proportions. It is estimated to have reached lengths of 9 to 10 meters, 30 to 33 feet, and heights of 4 to 5 meters, 13 to 16 feet, making it the largest known therizinosaur and maniraptoran. The most striking feature of the Therizinosaurus was its gigantic claws. Each of its forelimbs sported 3 digits, each tipped with claws that could measure up to 70 centimeters, approximately 2.3 feet in length, with the longest claw on the first digit. These claws are considered the longest known from any terrestrial animal. Unlike most theropods that walked on 3 toes, the Therizinosaurus's feet rested on 4, supporting its hefty build. Diet. The diet of the Therizinosaurus remains a topic of debate among scientists due to the lack of skull material that could provide definitive evidence. However, the consensus leans towards it being primarily herbivorous, similar to its therizinosaur relatives. Its enormous claws are thought to have been used for pulling down high branches for consumption, or possibly for ripping open giant termite nests. Given its size and the nature of its closest relatives, a plant-based diet seems most likely, although it could have been omnivorous, supplementing its diet with insects or other small animals. Era and discovery. The first fossils attributed to Therizinosaurus were unearthed during a Soviet-Mongolian fossil expedition in 1948. This expedition, aimed at exploring the Namek Formation in Mongolia's Gobi Desert, unveiled several giant claws and other skeletal parts, initially believed to belong to a large turtle. It wasn't until subsequent discoveries and analyses, particularly in the 1970s and beyond, that the true nature of these fossils was understood. Russian paleontologist Yevgeny Maleev named the species in 1954, but it was Anatoly Konstantinovich Rozdestvensky who correctly identified it as a theropod dinosaur in 1970. Further excavations throughout the 1960s to the 1980s shed more light on this enigmatic creature, piecing together a more comprehensive picture of its anatomy and lifestyle. These discoveries underscored the Therizinosaurus's place as a unique and significant member of the dinosaur kingdom, captivating the imagination of scientists and enthusiasts alike. Meganeuropsis, the giant dragonfly. Wingspan and appearance. The Meganeuropsis, a prehistoric dragonfly, reigns as the largest insect ever known to have graced the Earth. Living approximately 275 million years ago during the late Permian era, these giant dragonflies boasted a wingspan close to 30 inches or 2.5 feet, 75 centimeters, with an estimated weight surpassing 1 pound, 450 g, mirroring the size and weight of a crow. Their impressive size and predatory nature made them formidable creatures of their time. The Meganeuropsis permiana, in particular, was distinguished by its colossal wingspan, which was estimated to have ranged between 28 and 75 centimeters, 11 and 30 inches, making it the largest known insect to have ever lived. The body size of this species was estimated to be between 17 and 43 centimeters, 7 and 17 inches, further emphasizing its gigantic stature. Habitat and era. Meganeuropsis permiana thrived in the lush environments of the late Permian period, about 275 million years ago. The first discovery of this ancient dragonfly was made in the Wellington Formation of Kansas, United States, a sedimentary rock formation dating back to the early Permian period, known for its rich fossil records of insects, fish, and amphibians. Beyond North America, fossils of Meganeuropsis permiana have also been unearthed in other parts of the world, including France, Russia, and China, indicating a wide distribution across ancient Earth. This era was characterized by diverse ecosystems where Meganeuropsis permiana could dominate as a top predator, feasting on small vertebrates such as amphibians and small mammals, and possibly other insects. Theories on size. The astonishing size of Meganeuropsis permiana and other large insects of the prehistoric era has been a subject of much speculation and research. One prevailing theory suggests that the high oxygen levels in the atmosphere during the Permian period facilitated the growth of these insects to such immense sizes. The Carboniferous period saw a significant increase in global oxygen levels, allowing many land-living invertebrates to achieve considerable dimensions. Another theory posits that the absence of aerial vertebrate predators during the Carboniferous and Permian periods allowed insects like Meganeuropsis to evolve to their maximum sizes, potentially driven by an evolutionary arms race for increased body size between plant feeding and predatory insects. Additionally, It has been suggested that insects developing in water before transitioning to terrestrial adulthood could have grown larger as a means of protection against the high oxygen levels. These theories collectively contribute to our understanding of why Meganeuropsis permiana and other meganeurids were able to reach such unprecedented sizes compared to their modern relatives. Eurypterid, the sea scorpion. Eurypterids, commonly known as sea scorpions, represent a fascinating chapter in the history of life on Earth. These extinct arthropods, closely related to modern scorpions, spiders, and horseshoe crabs, thrived in various aquatic environments over 200 million years ago. Their remarkable size, predatory behavior, and widespread fossil discoveries offer intriguing insights into the ecosystems of the past. Size and description. Eurypterids showcased a remarkable range in size, influenced by their lifestyle, environment, and evolutionary lineage. Most species averaged around 100 centimeters, 3.3 feet, in length, but the group also boasted the largest known arthropod, Gcolopterus rhenanii. A fossilized chelicera, claw, from this species measured an astonishing 36.4 centimeters, 14.3 in, despite missing a portion, suggesting a total body length of approximately 2.5 meters, 8.2 feet, when including its extended chelicerae. This size surpasses other giant arthropods by nearly half a meter, 1.64 feet, even without considering the extended claws. Eurypterids typically had a lightweight build, which was essential for their locomotion and minimized the energy costs associated with molting and respiration. The pterygonids, a subgroup within the eurypterids, were particularly noted for their thin, unmineralized exoskeleton segments, contributing to their immense size. Habitat and predatory behavior. Eurypterids were most commonly found in rocks of the Silurian age, indicating their prominence over 400 million years ago. They inhabited diverse environments across the globe, from shallow, brackish and freshwater to possibly venturing onto land. The pterygonid eurypterids, among the largest of their kind, were capable swimmers that could traverse open oceans. Their formidable claws and binocular vision allowed them to slice into prey, which likely included primitive fish and cephalopod ancestors. Despite their fearsome appearance and size, recent research suggests that some, like the pterygonids, might have been nocturnal scavengers rather than apex predators, relying on their less developed eyesight to locate food. Fossil discoveries. The first eurypterid fossils were identified in the early 19th century, with over 250 species described since then. Their fossils have been found in numerous locations worldwide, including the United States, Germany, and the Czech Republic. Notably, the Yale Peabody Museum houses the largest and most diverse collection of eurypterids, amassed over nearly 50 years. This collection has yielded many new genera and species, along with beautifully preserved specimens that have enhanced our understanding of eurypterid diversity and ecology. The Birdie Group in New York and Ontario is particularly famous for its exquisitely preserved eurypterid fossils, offering a detailed glimpse into the environments these ancient creatures inhabited. Eurypterids' vast size range, predatory behavior, and the significant number of fossil discoveries contribute to our understanding of ancient aquatic ecosystems. Their existence underscores the dynamic and ever-changing nature of life on Earth, offering valuable lessons. ABO. Arctodus smilis, the short-faced bear. Physical characteristics. Arctodus simus, often mistaken as the largest bear to have ever roamed the planet, did not surpass the size of the modern polar bear or its southern kin, Arctotherium. Despite this, its physical prowess was undeniable. Adults could rear up to an imposing height of 11 to 13 feet and sprint at astonishing speeds of 30 to 40 miles per hour. This bear weighed around 1 ton, 2,000 pounds, with some fossils suggesting even greater sizes. When standing on its hind legs, Arctodus could tower up to 10 feet tall, resembling a grizzly bear in stature. Its unique physical trait, the forward-facing toes, differed from the inward direction of today's bears, supporting its fast and efficient gait. Diet and hunting. Arctodus simus was a formidable carnivore, equipped with large canine teeth at least 2 inches long and powerful molars designed for crushing bone. This bear's diet included dire wolves, bison, horses, and American cave lions, showcasing its capability to take down and digest large mammals. Its hunting prowess was further enhanced by a superb sense of smell and the ability to reach speeds of 40 miles per hour, making it an efficient predator and scavenger. Despite its carnivorous diet, evidence suggests Arctidus also consumed plants, indicating an omnivorous diet that varied across its range. The bear's diet and hunting methods have been a topic of debate, with some suggesting it scavenged more than it hunted, akin to a modern African hyena. Era and interaction with humans. Arctidus simus thrived during the early to middle part of the Pleistocene age, with its presence documented across North America. The extinction of Arctidus simus has been attributed to various factors, including competition with the Clovis people, who utilized spears to hunt large mammals, a primary food source for the bear. Another theory suggests that the glaciation of the Pleistocene age played a significant role in the bear's extinction. Despite its disappearance, the legacy of Arctidus simus as one of the most intriguing and formidable predators of the Pleistocene epoch remains undisputed.